Hi, welcome to Kriya. Before diving into servo homing, let's start with the breadboard, the simplest way to prototype electronics safely and easily. A breadboard is a plastic board with tiny holes where you can plug in wires and components like LEDs, resistors, and sensors. There's no need for soldering, and everything is temporary and reusable. Now, by the magic of buying two, I've already taken one apart so that I can show you its inner workings. Inside, metal clips connect holes in rows of 5. That means anything plugged into the same row is electrically connected. These long rows on the edge of the breadboard are called power rails, usually marked by the plus and minus signs. They let you connect your battery or power supply. This is a servo motor. Servo motors are small but powerful motors that can rotate to a specific angle with precision. Unlike regular motors that just spin continuously, servo motors move to an exact position and hold it there. When you first power on a servo motor, it doesn't automatically know the orientation of the attachment fixed to it. That's where servo homing comes in. Servo homing means moving the servo to a known reference point. Once this home point is set, all movements are relative to it. Let's take a quick look at this demo. I've 3D printed this dial and attached a servo to it. Now if I just randomly place the needle and power on the microcontroller, it won't line up with the markings on the dial. To fix this, we need to first move the servo to a known reference point and then attach the needle. As you can see, the angle of the servo now matches the angle on the dial. Alright, let's get started by placing the ESP on the breadboard. Hold it with both hands and gently push it down with even pressure. Make sure you leave one empty row of slots on each side of the breadboard, and the very first pin of the ESP lines up with the very first row of the breadboard. Next, grab a male-to-male jumper wire, connect the ground pin of the ESP to the negative rail of the breadboard. Now, take a red jumper wire, connect the V-in pin on the ESP to the positive rail on the breadboard. Let's take a closer look. You can see the V-in pin is wired to the plus rail and the ground pin is wired to the minus rail. A servo motor has 3 wires. The brown wire is ground, the red wire is positive, and the orange wire is the signal. Let's start with the top servo. To make the connections easier, we'll extend its wires using male-to-male jumper cables. Black goes into ground, red goes into power, and yellow goes into the signal pin. We'll do the same for the slide servo. Black to ground, red to power, and this time, purple wire goes into the signal pin. Now, let's wire them up to the breadboard. For the top servo, connect the red jumper to the positive rail, black jumper to the negative rail, and the yellow jumper to the D5 pin. Now, for the slide servo, connect the red to the positive rail, black goes to the negative rail, and purple goes to pin D6. Alright, now plug the USB cable into your ESP board and connect the other end to the computer. Next, let's launch the Kriya station. On the left hand side, click the hamburger menu. Under Build, select Code. Before we upload anything, we need to install the required library. Click on the gear icon Then choose Install Library. Type in Adafruit TCS 34725 and hit Install. Once the installation is done, you'll see a confirmation message. Just close the dialog box. Click on Ports to scan all available ports. Click it again and select the one for your ESP board. Now, hit Upload Code. You should see the lights on your ESP flashing while the upload happens. Once it's done, you'll see a success message. Next, let's open the serial monitor. Click Start Serial. Then, go ahead and press the Reset button on your ESP board. The board will print out all available options on the serial monitor. Now, type the letter C and hit Send to calibrate. You'll see both the servos jiggle one by one, then settle into place. And just like that, your servos are homed.